Hey everyone, welcome to this explainer. Today we're going to explore a beautiful secret math trick that is literally hiding in plain sight all around us. We're talking about unlocking nature's secret by identifying axes of symmetry in everyday figures. It's kind of where geometry meets the real world, so let's just jump right in.
Okay, have you ever looked really closely at a bug or a plant and thought, wow, that looks perfectly, incredibly balanced, like it was actually designed by a mathematician? Think about it for a second. Have you ever noticed this secret math trick hiding in nature? Just look at this magnificent blue butterfly. Notice how the left side looks like an absolute exact mirror image of the right side? The spots, the curves, those deep shades of blue, they match up flawlessly. And you know, it's no accident. It's a geometric principle hard at work in biology. It's actually amazing how many things in our environment, like that butterfly or the ridges on this green leaf, can be divided into two perfectly equal parts. It's a property that preserves their natural beauty and creates this visual harmony that our brains just naturally love.
Section 1. What is bilateral symmetry?
Well, what exactly is bilateral symmetry? Mathematically speaking, if you have a flat shape, a plane figure, right, and you can fold it along a straight line, so the two parts perfectly coincide, meaning they overlap exactly with absolutely nothing sticking out, that shape has bilateral symmetry. It's kind of like closing a book, where the pages meet perfectly edge to edge.
And that exact fold line actually gets a special name. We don't just call it a crease, we call it the axis of symmetry. It's basically the invisible backbone of the figure, dictating exactly how the whole shape is balanced.
So, the absolutely crucial thing to remember here is that the parts on either side of that axis must have the exact same shape and the exact same area. It's a strict rule. They literally have to be absolute mirror twins of each other.
Section 2. Finding the secret axis.
Okay, let's look at a really common trap. If we draw a diagonal line right across a rectangle, it definitely divides the shape into two equal areas, right? Two identical triangles. But if we actually try to fold the rectangle along that diagonal line, the two parts do not match up. The corners will just poke out on opposite sides.
And this brilliantly illustrates a major rule. Having equal areas doesn't automatically mean you have an axis of symmetry. If a line divides a figure into equal areas, but they don't perfectly coincide when folded, it is definitely not an axis. The ultimate test is always the fold. Now, when you're drawing these figures on grid paper, the real secret is making sure the corners, or vertices, on the left side are the exact same distance from the axis as the matching vertices on the right side. So if a point is 3 squares to the left of your line, its twin point has to be plotted exactly 3 squares to the right. It's like a giant puzzle.
Here's a fun, surprising fact for you. Did you know a perfectly flat circle, a circular lamina, actually has an infinite number of axes of symmetry? Since it's perfectly round, literally any straight line passing directly through its center will fold it into coinciding halves. That is way more than the 4 axes you'd find in a standard square.
Section 3. Creating your own shapes. This is where we get hands-on, and it's beautifully simple. Step 1, just fold a piece of paper in two. Step 2, draw half a shape right on the fold. Step 3, cut it out and unfold it. Bam! What you get is a perfect figure, where your very first fold is the exact axis of symmetry.
Or you can get a little messy and use paint. Just fold a paper, open it up, put a drop of paint right on that crease, fold it back over, squish it down, and unfold. You create this incredibly beautiful, totally unique symmetric art mirrored perfectly across the axis.
Section 4. The Symmetry Challenge.
Okay, let's do a super quick recap. True bilateral symmetry means the halves absolutely must have the same shape, same area, and perfectly coincide when folded. And that fold line is your axis. Just remember that rectangle trap from earlier. Equal areas are for sure not enough if they don't perfectly coincide. To wrap things up, I'm going to leave you with this provocative challenge to ponder. If you perfectly cut a symmetric figure into two halves right down its axis, will those two brand new pieces also be symmetric? Will they have their own axes of symmetry? Think about that. Maybe grab some scissors and paper to test it out yourself. Keep exploring the math hiding in plain sight, and I'll see you next time.